Welcome, Earthlings, to another video on Trig identities. 2 of 2, not 1. 2 divided by 2 is 1, but this is second of 2 videos in the Analytic Trig unit. Let's get analytical. More identities. Don't judge, analyze. Here we go. You ready? More identities. Cofunction, check it out. We got some cofunction identities. Let me sketch a little picture for you. On the left of your notes, I have a little triangle I'd like to share with you, and it goes something like this. We're just going to create a right triangle. Oh, let's make it so that it's not so 45, 45, 90-ish. Okay? And let's say theta is down here. This is a right triangle. And call that R, call this X, call this Y. The cofunction identities are all about functions that are functions complementary, like sine and cosine, and tangent and cotangent, and secant and cosecant. That could get really annoying after a while, don't you think, Allison? Okay, check it out. The other angle inside this triangle is, well, I can't write it that small, is pi over 2 minus theta. 90 degrees minus theta, because that's all that's left inside that particular triangle. Okay, so see if you could squeeze that in that space there, and I will expand on these cofunction identities. There are 6 of them. Really, we just memorize one and we know them all. So the first one is sine of pi over 2 minus theta. Pi over 2 minus theta. What does that mean? What does that mean? Okay, that's equal to cosine of theta. Don't just take my word for it. Stand at the pi over 2 minus theta angle and calculate sine of that angle. So sine of that would be opposite x over hypotenuse, r. X over r, x over r. Remember that. Now, let's calculate cosine theta. So we're standing at theta at the corner, the vertex, and we're going to calculate cosine adjacent x over r hypotenuse. X over r. Oh my gosh, that's the same thing. That's because they're inside the same triangle and they're complements, meaning they both add up to 90. So the reverse is just saying cosine of pi over 2 minus theta equals sine theta. So notice how if you just memorize one, you know them both. Okay, the next pair, well, you know. Let's do this. Let's get a little crazy. Let's write tangent next. Analyzing minus theta, and that's equal to cotangent, because it's complementary tangent and cotangent. Okay, super duper. Here we go. And this next one is cotangent of pi over 2 minus theta equals tangent theta. And as I write this last one, I'm going to think of complements in our class. Who complements each other? Oh, I don't know. Let's think of someone who writes really small and really big. How about Jackson and William? They got complementary handwritings. Complement each other. How about when we're playing competitive games? Oh, Max and Elena. Such complements there. There's the last one. There are your 6 cofunction identities. And speaking of complementary complements, something about in his handwriting, something about Abby's handwriting. You should check it out one day if you haven't seen it. It's very good. It's very good. So I bet her notes on this are very good. Fitting it all inside the boxes. All right, these are the last identities I'm going to share with you. All right, that means that we just have everything we need to do a bunch of the puzzle solving as we work through some of the questions. These are even identities. All right, these are not a big idea, which is why these are presented last. So what we're going to do is I'm going to write just one pair here, and then I'll tell you what they are. So sine of negative x, and this could be negative theta or negative whatever, it doesn't matter. Sine of negative x is negative sine x. That's equivalent. Remember way back when we were studying even and odd functions. An even function is reciprocal around the y-axis. An odd function is, did I say reciprocal? It's symmetrical. An odd function is symmetrical around the origin. So sine is symmetrical around the origin. If you plug in an x, then if you plug in a negative x, you'll get a value that's opposite that quadrant. So quadrant 1 and quadrant 3, or quadrant 2 and quadrant 4. All right, so the other one that kind of goes with this to the right is cosecant negative x. So because sine is odd, cosecant is odd. And we're going to put an O next to those. O for odd. Then we're going to do even ones. So cosine of negative x is equal to cosine x. Meaning if you plug in your calculator right now, cosine of negative 3, pick a number, it doesn't matter. Cosine of negative 3, and then you do cosine of 3, it's going to give you the same exact number. That's wild. Because it's symmetrical around the y-axis. So its reciprocal function is also symmetrical around the y-axis. And it makes for quite the curve. It's really nice. It's really great looking. To sketch secant, you just type in y equals 1 over cosine x. So those two are even. Those are the only two even ones. And your last one, tangent of negative x is equal to negative tangent x. So here's a quick sketch of tangent. You could see why it's odd. It's symmetrical around the origin. Not the best sketch, but if you rotate it 180 degrees, you get the same curve. So cotangent of negative x equals cotangent x. So that's odd, both of those. So if I add up all of the identities that I shared with you in 2 videos, it's 20-something, 23 I think, 23 identities. But when we take away the 6 that you already know, keep the 5 that are brand new, quotient and Pythagorean, only focus on one cofunction identity, and maybe 3 here. We have 3, 4, 7, 9 total. I think you could do it. And the only way that we'll memorize some of these is if we just practice using them. So let's practice that right now, and we'll just take a look at an example of how to simplify an expression. This is the only example I'm going to give you right now, and the rest of it is just using some of your analytical skills or improving on them by just finding patterns, looking for how it connects. And so after this one, we're just going to take a look at some of your exercises and try to find out, what's the category for each one. So the reason I gave you those quick review questions at the beginning is I wanted you to remind yourself of how you factored. And so that's going to be a big factor, that's a good one, in some of the work that we do. So I want you to notice that cosine is consistent, shows up in both of these expressions here. So we're just going to factor out a cosine x. All right, so cosine x. And when we do that, we're factoring out a cosine x out of cosine cubed, so we end up with cosine squared x. And we factor out the cosine x that's hanging out with sine squared, so we're just left with sine squared x. So factoring, whether it's greatest common factor in this case, or factoring in binomials, or the difference in 2 squares, those are things that show up in various ways. All right, now I'm looking at this expression, I'm thinking, oh my gosh, I think I know, okay, I think there's something that I could use to simplify this expression. And I look back at the Pythagorean identities, because they have squared units. It's the only one that stuff is squared. And I see that cosine squared plus sine squared, or reverse, sine squared plus cosine squared, is simply 1. So this is cosine x times 1, which is cosine x. So basically what I just did was I proved that cosine cubed x plus cosine x sine squared x is equal to cosine x. I could write that as a 2-column proof, and I've shown it. So that's what you'll do as you practice some of these exercises, and the exercises will just throw a bunch of various situations at you, and you'll have to figure it out. Okay, here we go, Stivers. We're going to turn the page. We're going to check out the homework. You with me, Mary Mead? Here we go. Turning the page. Can you check out number 3? So we're just looking at our page now. If you're watching this just to get the content, we're done with the content, and then this is just to set up some of the exercises that we have in class. So we're starting at number 3, and I don't really have anything to share with you about number 3. You're just going to use an identity, and you have to find it. And I'm looking at number 4. You're using an identity. You could find it. I know you can do it. But here's a little shortcut. I want you to think about this, maybe make a quick note. In that first expression, sine of theta minus pi over 2, factor out a negative 1. So you can reverse that. Factor out a negative 1. So just write factor negative 1. Number 6 is a great test question. Turns the page. And we're going to go all the way up to 12 to start with. Many of them are just 1 or 2 steps. When I'm looking at number 7, I could separate. I'm looking at number 7, I'm thinking Pythagorean identity. So you could write PYTH. Number 8, you can do it. Number 9. Number 9, you might have to. I don't have anything to say about that. Okay. Number 10. Number 10 is a little bit more complicated. And so in that particular case, there comes a point where you might have to divide fractions by fractions. So dividing fractions. And number 11. Okay, I think number 11 is one of the harder ones, but I think you could totally do it. So here's the gist. Right above cosecant x minus sine x, I want you to write a squared. And then above the next expression, I want you to write b squared. So that's in the form a squared minus b squared, just like what we practiced at the beginning of this video. All right, so if you identify that and you factor it in terms of a minus b and a plus b, or vice versa, then you'll end up being able to cancel some terms away. All right, so that's a little bit longer, so you can save that one for last. Do 12 before that. And 12, one little thing I'm going to share with you in a few days is that if you turn every expression or every term into sines and cosines, you'll be able to simplify fairly easily. Yeah, there we go. That's a wrap. I believe in you. Practice your analytical skills, and thanks for joining me on more identities. Terminate program.